I just forgot to mention that what makes internal waves so important in the ocean is that in regions where they are created, they can actually lift nutrient-enriched deeper water into the euphotic zone. And if you now imagine that the blue water here in this example is a nutrient-enriched water, and you see a vertical transect here, and you can see that occasionally the blue water is moved to just 20 meters below the sea surface, which is well inside the euphotic zone. And you can see that overall this induces a subsurface plankton bloom. If the internal wave reaches the surface, it can also create surface plankton blooms over time. That's the average effect of that. Okay, let's talk about the last feature here. So here are some images of internal waves. You can see them at the sea surface through regions which look more rougher, which have a more rougher look. You can see that they're in this image here. Regions which are relatively smooth, and then there are regions which have lots of ripples. And these are sort of capillary waves type of thing. But in some regions, you have a flow divergence, which moves water away from a point. And this actually leads, it stretches the sea surface and makes the sea surface smoother. And in other regions, you have a convergence, and the convergence actually compresses these little ripples, and the sea surface appears rougher. Okay? And you can actually determine these type of features with special satellite techniques, which can identify very, very short wavelengths, so-called Bragg wavelength. But now let's talk about dead water phenomenon. Okay, and your grandma asks you, hey, let's go onto a Norwegian fjord, and we take our boat, okay, and let's steam full speed. Okay, there's no wind, okay, but no tides, nothing, absolutely nothing there, and all of a sudden you are stuck in the middle of the fjord. A little image shown here in the bottom. Okay. Grandma complains, why are we stuck? There must be something. And this is known as the dead water phenomenon. Okay? So what happens in this situation is that you are in a two-layer system, which has a very low salinity surface water, just from the melt of the glaciers, okay? And above seawater. In a situation where your engine, the propeller of your engine, sits exactly at the interface between the two layers. So what you do with the engine, you go hard, full speed, is you actually, rather than propelling yourself forward, or what you actually create internal waves that move backwards. And this is the dead water phenomenon that you only experience in these very strongly stratified system, so you wouldn't see anything like this in South Australian Gulfs. Okay, this is what we call the dead water phenomenon.